Hi everyone, this is Sally Quast, and I'm going to do the lecture on Chapter 3 in the Introductory Chemistry Concepts and Critical Thinking, the 7th edition by Charles Corwin. I have the lecture in three parts, mainly because of the size. I think it's easier to load them if they have the smaller ones, and then after each one, each lecture, there is a homework assignment on mastering chemistry. This is week 3 of the summer class, and we're doing chapter 3 and chapter 4. So this chapter 3 assignment is due for Tuesday, and then the chapter 4 assignment will be due on next Sunday. So we'll begin the lecture, and chapter 3 is on matter and energy. And the question is, what is matter? And I found this picture of the Earth from space. It's really one of my very favorite pictures. What it reminds me of is no one's coming to save the Earth. We're either going to save it ourselves and take care of it or not. So when we talk about what is matter, we're talking about really the Earth. I mean, the Earth and the atmosphere. We're not really talking about what's outside our Earth. So that's the question. What is matter? Like, what is this Earth that we live on, that we're looking at here from outer space? We call it matter. That's what we call matter. Everything that's there we call matter. What is it? What makes it matter? Are there different kinds of matter? So this chapter is an exploration into a discussion of what matter is. So the definition of matter is any substance that has mass and occupies volume or takes up space. So anything that has mass and takes up space, we call that matter. So you're matter, I am matter, the laptop or the computer that you're working on is matter, the air we breathe is matter. So all of that is matter. And I like to say that your ticket to be on Earth, to be on the planet, is that you have to be matter. That's the ticket. If you're matter, then you get to be on the Earth. If you're not matter, well, you'll be energy, but that actually shows up in matter in some form. So one of the ways to organize matter is to talk about the states of matter. So we're going to look at different ways of organizing matter in this chapter. So one is the states of matter. So if you look at all of matter, you can organize it into 3 states: solid, liquid, and gas. There's also a 4th state called plasma, which is what the sun is. It's ionized gas, but for chemistry on the Earth under normal conditions, we can take all the matter, everything that exists, and we can identify it as either a solid, a liquid, or a gas. So we want to look at what makes a solid, what makes a liquid, what makes a gas, how are solids different than liquids. So I picked this chart from the textbook, and there's a lot of reading in the textbook. If you want to do the reading in chapter 3, it'll give you this information pretty much in word form, and I like it so that I like this because I like charts. I'm a visual learner. So here's matter, and if you look at it, you have matter. You have solid, liquid, and gas. So they show you solid, and liquid, and gas. And it looks something familiar to us all. So here we have ice. Here we have water in the liquid state, and here we have steam coming out of a kettle. So that's in the vapor state. Now down here below it, in the diagram, we show you the molecules, H2O molecules, and what we believe are the difference in the molecules between a solid, liquid, and gas. And as you can see, what's the same about them is they're all H2O. They look the same, but what's different as you go from a solid to a liquid to gas, they get farther and farther apart. So if you look at the chart at the top, we have 3 properties we can talk about with states of matter. We can talk about shape, the shape of something. We can talk about volume, that's how much space it takes up. Or another term is compressibility. That's how much can it be, formed, like smooch, I don't know, compacted. That's probably a good word. So if you look at the top, solid, liquid, and gas, so a solid has a fixed shape. We say it has a definite shape. It also has a fixed volume, a definite volume. Another way you'll hear it spoken about is that it stands on its own. A solid can stand on its own. A liquid, on the other hand, has a variable shape. So a liquid will take the shape of whatever container you put it in. So if you put a gallon of milk in a quart container, you'll have a mess, right? Because the quart container will only hold a quart, and if you try to put a gallon there, it's not going to fit. But it has a fixed volume, and that's why, because a gallon is a gallon, and you can't put it in a quart container. But you could put a gallon into a box, or you could put it into a gallon jug. You could use all different kinds of containers, and they would hold the liquid. But that's not true with a solid. The solid just stands on its own. Compressibility, ability for it to be compressed, is negligible also for liquids. And if you look at the picture down there of the molecules, you'll see there is a little bit of space between the molecules. All right, you have a little bit of space down here between the molecules compared to the solid state. But so there's a little bit, but they say negligible. All right, then for a gas, the shape of a gas is variable, its volume is variable, and that means it takes the shape and volume of the container. If I sprayed perfume in the front of a room, within a very short period of time, people in the back of the room would smell it. My favorite example are skunks. You know, if a skunk gives off its odor, it's a gas, you know, it fills up a neighborhood. You'd think the skunk was next door. You know, who knows where the skunk is, but it doesn't take long before it fills up all the space. So the volume and shape are indefinite, and compressibility is significant. So that's one of the things that we can do with gases, is we can compress them. So if you look at that molecule, the model in the bottom of the page there, you'll see that these molecules are very, very far apart from each other compared to a liquid or a solid. So here's a summary of the state changes. Okay, we're going to change states. So in order to go from the states from a solid to a liquid to a gas, the way that can be done is by adding heat, increasing the temperature. The process of going from ice to water is called melting, and you want to know these terms. Okay, these are terms you need to know. The process to go from water to water vapor is called vaporizing, and this shows you what it looks like below it there in a physical sense. Now if you come back the other way, if you're going from a gas to a liquid, it's called condensing, and it is losing the temperature. It's getting colder. Okay, you're taking heat out. If you go from a liquid to a freezing, then we liquid to a solid, we call that freezing. So when you go from a solid to a liquid, we call it melting. Going from a liquid to a solid, we call it freezing. Okay, over here it's vaporizing and condensing. Now there's one other condition that we have, and that is going from a solid directly to a gas. And one of the substances in matter that does that is iodine. Iodine will do that. If you leave iodine out on a counter, it will go into the gas state. Another one is called mothballs. Did you ever wonder what happened to mothballs? You know, you put them in a box. There were mothballs in the chemistry lab. Yes, this week I was up there in Lowell, and they didn't have a lid on them, and the box was empty because all the mothballs, which were solid, went directly from a solid to a gas, and that's called sublimation. Dry ice is the same idea. Dry ice goes from a solid to a gas. That's the whole chemistry behind cooling. They use dry ice in for those carts that they have ice cream in summer. I don't know, now they have refrigerated, but a long time ago they used to have these. If you see these carts that are out there and they have cold things in them, what they usually have are big chunks of dry ice, because the dry ice, which is CO2, will go from solid to a gas, and they don't have to deal with liquid and all that mess that it has if it's in the liquid state. Now if you go in the reverse direction from a gas to a solid, the name of that, and it's not something we hear all the time, but that's the name of it, is deposition. So you want to know the names of each in each direction. All right, so you go from solid to a gas, or you go from gas to a solid. So this is a summary of the state changes. Temperature is the thing that makes it happen. Same molecules, same substance, all right? Just gets farther, and the molecules get farther and farther apart from each other. Now the next thing I'm going to look at is matter, another way to organize matter. And I put this flow chart in the beginning and the end of the discussion. And at the end of this, you'll have time to go do the homework problems on mastering chemistry. So this is another way we can organize matter. And if you took all of matter and you organized it, one way you could do that is you could organize it into mixtures, and you could pure substances. That's another way to take everything that exists on the planet. You could say it's either a mixture or a pure substance. And the relationship between mixtures and pure substances is that you can separate mixtures physically and get the pure substances that they're made of. All right, so they're a physical combination of matter. There are two kinds of mixtures, which are heterogeneous, meaning that they are unevenly mixed. If you look at this one, the picture in the bottom, you have molecules, different kinds of molecules. That looks like oil and vinegar down there. Okay, you have oil and vinegar. All right, and see, the oil is lighter than the water, so I mean oil and water. So here's the oil up here, there's the oil molecules. Underneath in the bottom you have the water molecules. And then the picture next to it is a homogeneous mixture, and in chemistry we call that a solution. That's the name of a solution. And what makes it homogeneous is that it's uniform throughout. So if you look at that picture below, you'll see that the molecules are mixed evenly together. So that's mixtures. Now the other thing we have are pure substances, and they can be, compounds can be separated into elements chemically by a chemical means. So here we have a compound, that's water, and if you look at the molecules below it, and then next to that we have gold, and if you look at an element, that's an element. An element in the picture is only one kind of atom, and in the compound there's only one kind of molecule, for that case H2O. Now I'm going to go through the word part of this, okay? So classifications of matter. Matter can be divided into two classes, mixtures and pure substances. Mixtures are composed of more than one substance and can be physically separated into the components. Pure substances are composed of only one substance and cannot be physically separated. There are two types of mixtures. There are heterogeneous mixtures and homogeneous mixtures. And we looked at that in the chart. Heterogeneous mixtures do not have uniform properties throughout. Sand and water is a heterogeneous mixture. Oil and vinegar and salad dressing is. If you ever looked at salad dressing, all the oil sits on top. Or oil and water. That's another heterogeneous mixture. Homogeneous mixtures have uniform properties throughout. Salt water is a homogeneous mixture. If you made a sugar water solution, that would be homogeneous. Soda is homogeneous. Jello, if you ever did liquid jello, jello before you chill it, that would be a homogeneous mixture. Can be separated to the original components. Pure substances, there are two types of pure substances, compounds and elements. Compounds can be chemically separated into the elements. Water is a compound that can be separated into hydrogen and oxygen. An element cannot be broken down further by chemical reactions. So elements are the simplest form of matter. We call them the building blocks of matter. And this is the chart that I had at the beginning. Okay, so you can now look at this and maybe it's a little bit clearer for you. So that's the end of the first lecture. And what I would recommend that you go now is the Mastery Chemistry site and do the homework for Chapter 3, homework number 1, and you start with the beginning exercise. I think the first is a tutorial, and then go up to exercise 316. And then after you complete the exercise, you can return to the slides for the second lecture.